Now that we know what a radian is, how many do we think are in one revolution, right? We had 360 degrees in one revolution. How many radians? Okay. Well, it ends up, it's not going to be a whole number, not a nice number. But I wouldn't call it a bad one either. Okay. 1 radian covers an arc of r units, while the circumference of a circle is 2 pi r units. And since r goes into 2 pi r 2 pi times, that means that we have 2 pi radians in a complete revolution. Okay, and so this is going to be something we want to remember. 1 revolution is 2 pi radians. All right, next, we've actually already made this connection. We just haven't formally written it down. If we look back up at our picture here, you might notice that the arc length is always the number of radians times r, right? 3r, 2r, 1r. So down here, the formula that's going to actually relate s, r, and theta is just s is equal to r theta. Okay. And down here, we're actually going to solve that equation for theta. And if we do that, we get theta equals s over r. All right, let's jump into an example. So we can use either one of these forms of this equation here to do number 1. Okay, and it says find the length of the arc on a circle of radius 24 intercepted by a central angle of pi over 4. And actually, since we're being asked to find the length of an arc, well, a length of an arc, that's just s. Okay, so this is s. Here's our radius, and here's our angle theta. Okay. Well, it would make the most sense to me to use the one that's already solved for s. So we have s equals r theta. S equals r theta. And r for us again is 24. Our central angle is pi over 4. And 24 divided by 4, well, that's 6. So we just end up with 6 pi here. Okay. All right, so you might have had a question about maybe whether we can convert back and forth between degrees and radians, like we convert between feet and yards or meters and kilometers. And yeah, we can convert back and forth between degrees and radians, and it's actually pretty easy. If we were to do this, we need to either know 360 degrees is 2 pi radians, or I prefer 180 is equal to pi radians. And I prefer this one because it's going to make us have smaller numbers to work with. Okay. Now, I here says to convert degrees to radians, multiply degrees by blah. Okay, well, let's actually just start off with an example, and then we'll come fill this in. Okay, so if we start off with that minus 270, minus 270 degrees, well, is what we really would like to do is be able to multiply by something so that the resulting units are in radians rather than degrees. Well, 180 degrees is equivalent to pi radians, And the fact that we put the degrees on the bottom here means that our degrees are going to cancel, and we're going to be left with radians. Okay? And so if we simplify that minus 270 over 180, it's going to give us minus 3/2. But don't forget about the pi we have here. So minus 3 pi over 2. Okay. Right? And one thing that I haven't explicitly written in the notes here, but that is, if we are writing something in degrees, we will write the degree symbol. And if you don't see the degree symbol, you can assume it's in radians. Okay? And especially if you see a pi, there's a good chance that it's in radians. Okay. Right? So is what we did learn in this example here is if we want to convert from degrees to radians, then we want to multiply by pi radians over 180 degrees. Okay. It would technically also work if you did if you did 2 pi radians over 360 degrees. Okay. But again, if you do that, you're going to have to do a little bit more simplification. I don't really want to do that. So next we want to see, well, how do you convert from radians to degrees? We're really just going to do the opposite thing. If we multiply by 180 degrees over pi radians, well, then we'll get the radians to cancel and we'll be left with degrees. Okay, and let's see this happen. Okay. With this 7 pi over 6 radians. Okay. I'm going to put my 180 degrees on top because that's what I want to be left with. And again, I want to make the radians cancel. Okay. And so if we multiply all this together, you can see that the pi's are actually going to cancel. So it's just whatever 7/6 times 180 is. Okay. And so it's going to come out to 210 degrees. The next thing that we're going to do here is try and get comfortable working in radians. We're all comfortable in degrees because we've been working with them for a long time, but we need to get that way with radians here too. Okay. And the way that we're going to actually do parts A, B, and C here is if we want to plot or sketch the angle pi over 4, why don't we just figure out what portion of a revolution it is? Because that's something that we can easily visualize. So if you were to take that pi over 4, and again, see what portion it is of a full revolution. Well, full revolution's 2 pi. Right? And if you don't remember how to divide something like this, that's all right. We can rewrite this as pi over 4. And notice we have a fraction on top. And on the bottom, we're also going to have a fraction, 2 pi over 1. Okay? And the reason that this is helpful is we know that if we were to divide two fractions, we're supposed to flip the second one and multiply. Or in this case, the bottom one and multiply. So pi over 4 times 1 over 2 pi. And so our pi's are going to cancel, and we're actually going to end up with 1/8 of a revolution. Okay. But I have one more question for you. 1/8 revolution in what direction? If we go back up here, pi over 4, this is a positive angle, so this should be in the counterclockwise direction. Okay. So let's go ahead and sketch it. We should have our initial side here right on the x-axis. Okay. And again, we want to do 1/8 of a revolution counterclockwise from here. Okay. Well, this spot right here, that's a quarter of a revolution. So 1/8 is just half of this. So if you half this, that would look like a 45-degree angle, or because in fact it would be one. Okay. So I'm going to go ahead and try and sketch that in here now. All right, and that looks pretty good. Okay. Okay. And let's try the next one. Okay, notice this is a negative angle, so we already know we're going to be going in the clockwise direction. Okay. And I'm not even going to worry about the sign because, again, all it tells me is whether it's clockwise or counterclockwise. I just want to figure out how many revolutions right now. So pi over 6 is what portion of 2 pi? Okay. And we can use the same trick here, pi over 6 all over 2 pi over 1. And then we can take that bottom fraction, we can flip it over. So instead of 2 pi over 1, it's 1 over 2 pi. And so this is going to come out to, well, the pi's are going to cancel. We're just going to get 1/12 of a revolution. All right. And again, this was clockwise. And let's try and sketch it. So once again, we're going to put that initial side on the positive x-axis. All right, so there's our initial side. And then we're going to try and do what looks like 1/12 of a revolution. Okay. So if we're going to try and do 1/12 of a revolution, let's maybe start off with 1/4 of a revolution, okay, before we talk about 1/12. So if we were to go back here a full quarter of a revolution, right? That'd be right here. And if you were to split 1/4 by 3, divide it by 3, okay, you will get 1/12. 1/4 divided by 3 is 1/12. So I'm going to try and do about 1/3 of this quarter rotation. It's not going to be perfect. I don't have a protractor here, and that's okay. But again, I'll try and do 1/3 of a quarter revolution, okay, which is 1/12 the revolution. And I think that looks pretty reasonable. Okay. And I'm just going to ignore that these lines don't meet up perfectly here at the origin, but that was my intent. And so this is our angle minus pi over 6.